So yesterday we started moving all of our object info into our play state. So instead we were instantiating an egg inside our vulture class, and then we were instantiating a jockey in our egg class. That's why we were getting the vulture.egg.jockey, but that was giving us problems. In the collision detection, if you collected one jockey, it triggered all the jockeys, so we're moving them into our play state so we can check our global table of eggs and our global table of jockeys and our global table of vultures instead of the nested vulture.egg.jockey. So that's what we did yesterday. I mean, it's been in the process the past 2 days, and we still have, let's see, left me a note where we left off. Where was it? Right here. So we were doing egg hatching inside our egg class, which instead we're gonna have to, because our jockey instantiation is tied to our egg hatching and our hatching animation, we have to move this jockey instantiation out into our play state, and in order to do that, we have to move our actually, maybe, hold on, let me think. So if in our play state we check this hatch animation of each, I don't know. I'm trying to decide if we need to move this, well, like what exactly we need to move out of this egg class, because it makes sense for the egg hatch countdown to be inside the egg class. And then, so maybe we only move this one out. We only check the hatched animation, because there's a couple frames that we're hatched that are still not a jockey on screen, and that's 0.4 of a second is how long that takes. So we're doing the hatch animation, doing those other 3 frames of the hatch animation if we're hatched, and then as soon as we're hatched, like the hatch triggers the hatching, but maybe we should have maybe this should be, if hatching, do the animation for hatch, and then if you're done with the animation for hatching, if you're done with the animation for hatching, then we're self-hatched. That's one way to do it. Or how we're doing it is just checking the hatch animation timer. It's just like everything in coding, it's going to be what you choose. Like, you could do it whatever way. So maybe for clarity's sake, I'll keep the hatching. I'll change this hatched boolean to hatching, and hatching controls the hatching animation. And once the hatching animation is greater than 0.4, and I'll add this boolean here, hatched gets true upon the hatching animation being greater than 0.4, and then in our play state we say if we're hatched, and not graveyard or something, because we have to have a way so that we only spawn one jockey. So we're going to say if we're hatched, spawn a jockey, set hatched equal to false, because hatched is the boolean we're using to spawn a jockey, and then it'll only spawn one, and then we move it to the graveyard and it counts as not hatched anymore, even though it technically is hatched, just it's in the graveyard, and we need hatched to be false. Something like that. But that makes more sense to me, because then we can keep the hatch countdown in the egg class, So whenever we do egg update, it'll update the hatch animation and the hatching boolean. I think that makes sense to me. But the thing is, we have to make sure we're not using our self-hatched, or like we have to make sure that anytime we use .hatched gets changed to not only the table iteration, we're not even doing it. Okay, I don't know where we were doing that. We were just doing it here in our egg class. We were just doing it here. But then, yeah, okay, it's just confusing. Oh yeah, man. And the scary thing is, I don't know if any of this will work. I don't know if taking these into the global tables will perform the same way, and we can't really test it because everything's busted right now because we're in the middle of migrating all this crap. But this is one of the last things we have to move, I think, because it's the last instantiation other than our print score objects, which we're gonna have to fucking figure out. But shit, god damn, it's just like, it's really daunting when you get to do, I've never done refactoring on that level before, because like just last episode we had 60 deletions, 200 insertions. I've never done refactoring of that scale before because I haven't had a code base that big before. Okay, let's do this. We're gonna say we need a hatching. Okay. And if we're hatching, that means we're in the process of hatching. So we need to change this. Hatching gets true if the hatch countdown is smaller than 0. If we start the hatch countdown, if we are dx of 0, meaning we've stopped our egg movement on the x-axis, and we're not collected already. So if we're collected, we don't do the hatch countdown. That makes sense. And we don't check for collected is in the collision, which is in play state, so we'll have to just make sure we are triggering that to false upon a player and egg collision, which I'm sure we are doing, but we'll just have to make sure. So then we're, oopsie. Okay. So now we are hatching if hatch countdown is smaller than 0, and if we're hatching, increment your hatch animation timer. And if our animation timer is below 0.1, it'll be the first frame. If it's below 0.2, it'll be this one. If it's below 0.3, and then when it hits 0.4, when it's greater than 0.4, we don't need jockey spawned. We don't need jockey spawned here. I know we added this to fix a bug, but this shouldn't be the case. We shouldn't need this. Because we're only gonna spawn our jockey. We're not gonna spawn our jockey here. We're only gonna spawn our jockey if we're hatched, which is our boolean that we still have. We just repurposed. So we're gonna say self.hatched gets true, hatching gets false, and if we're hatching, yeah, we'll no longer be hatching, so it shouldn't update the animation timer or anything after that. But then we need to see, and this is tricky because all of these aren't going to be self, it's going to be egg at the ith index dot hatching moved into our play state. And then whenever we check, we'll need to cycle through all our eggs and check, hey, if we're hatched, spawn a jockey, hatch gets false, moved graveyard, which is what we do right here. So we're going to move everything in comments. We're going to be moving to our play state because now we have a hatched boolean that we are going to trigger our wanted effect, which is to spawn a jockey in our play state into our jockey table at the ith index. And that just means if we're vulture 3, vulture at the third index, a vulture at the third index, when collided upon, will make an egg at the third index at the last x and y of the vulture. And then if you collect, or if you let an egg hatch of the egg in the third index, it'll make a jockey at the third index with the last x and y of the egg at the ith index. Instead of self here, it'll be egg at ith index in a for loop. I sound like I'm talking a different language. Okay, this should all work. He says before it's all busted and he can't figure it out. So we can keep the self-hatch animation and self-hatching and self-hatched. We just need to add in when we just need to add in the collision when we collide with an egg that, or actually, so this is for spawning of jockey. So we need to say, if we need to have a loop that's checking through if yeah, what do we say there? Do we say if eggs are not graveyard, then check to see, because if they're not in the graveyard, that means they're active on screen. And if they're active on screen, that means they're in the process of hatching. Not quite, until they stop moving on the x-axis, they're not in the process of hatching, but every egg needs to hatch if it's not collected. So we'll say if egg's not in graveyard, then if egg is hatched, spawn a jockey, move egg to graveyard. And if egg is hatched, that means automatically egg hatching is already false, because hatched can't become true unless hatching becomes false here. So we should only have to worry about that and then move to graveyard. And then I think that's the last of our, other than our print square objects, that's the last of our big migration. And then we can start seeing what's so busted, which I'm not looking forward to. But we'll keep going, The friction is real when I'm like trying to wrap my head around how big of a program this is now. We haven't even got multiple waves yet. We haven't even got the vultures upgrading yet. We haven't even got our jockeys to hatch properly yet. God damn. Okay, getting too far ahead of myself. Just one step at a time. I'll make sure I'm recording because for some reason I just forget if I hit record or whatnot. Okay, I'm gonna go to the bathroom real quick. Be right back. Sorry. Music stopped. Okay. So we're gonna go into our play state. Yeah. So, yeah, okay. We're in our play state and we're checking for, we're not doing a collision per se, we're just checking. We have to check if an egg, see, this is all jacked. Jockey spawned. Oh, well, no. Jockey spawned. Do we set jockey spawn to true upon a hatched? We should. So we can use that jockey spawned to say, hey, go through every egg if it's not in graveyard and check if jockey spawned. If jockey spawned, instantiated jockey, send our egg to the graveyard. That way it doesn't do it more than once, and then hatched gets false in our play state. So if egg.jockey spawned collides with jockey. Okay, so we need a, instead of player to object collision, well, yeah, it's not a player to object collision, it's just a if egged is hatched, it's just a spawn jockey. It's just a spawn jockey thing. So maybe we say up here, we say jockey spawn, oopsie, jockey spawn, and we're gonna say we've got to go through our tables in our wave 1, and we're gonna have to change this I for I is 1, 3. We have to change that to a self.wave or a wave option, whatever we call it, because that number needs to scale with the amount of vultures that are on a given wave. Right now it's hard-coded to 3 because all we have is wave 1, but we need to set that to a variable that changes depending on which wave we're in, which we just haven't got around to yet. So we're gonna have to change it. But for right now, it's all 3 because wave 1 just has 3 objects. 3 vultures means 3 eggs means 3 jockeys. So we're gonna say, we check all our eggs. We're gonna see if egg at the ith index, if eggs at the ith index dot graveyard, if not graveyard, meaning egg is on screen, then if the egg is on screen, if the eggs at the ith index is hatched, meaning hatching already happened, then we need to spawn our jockey, which is a jockey at the ith index at the egg's last x and egg's last y. So we'll say it's not self.jockey, we need to say our jockey's global table at the ith index, and that means if it's egg 3, it'll be jockey 3. jockey at ith index gets a jockey instantiation at, not self, but eggs at the I last x and eggs at the I last y. So it'll inherit, the jockey instantiation will inherit the last x and last y of our egg. But it's actually a little different than that because don't we shift it? I thought we had to shift the jockey because the jockey's taller than the egg. So we had to shift it. Maybe our last x. Huh. I could have sworn we had to shift it like that. But then we need to we need to take jockey out of the graveyard so it can get updated. Because if we don't, it'll give us a jockey, and then the very next frame it'll say, oh, jockey graveyard is true. And what do we do when graveyard jockey is true? We move it off screen. So we need to set it. We need to say jockey is no longer in the graveyard. So jockey's at the ith index. Dot graveyard gets reassigned to false, no longer in graveyard. Then we instantiate it with the egg's last position, and then jockey spawned gets true. Yep. So we'll need to say, well, if jockey spawned, we're doing this. So right now we're rendering the egg based on if jockey is spawned, which it should probably be if not self graveyard, because that makes more sense. And then I don't think we need jockey spawned unless we do something else in the play state with jockey spawned. We do. If the jockey is spawned, that's when we check for collision between the jockey and the player. So that makes sense. So we'll just say, oh crap, where is our here? So we'll say, hey, jockey's no longer in the graveyard. And by the way, that jockey, it's actually the egg.jockey spawned. So messed up about it. Egg.jockey spawned is not the way to do it. We need to move that into jockey. So we'll say, isn't that just not self graveyard then? I think it is. We can use graveyard as a spawn because we're just checking whether or not it's on screen. We don't need to render. Yeah, I think we can get rid of jockey spawned. I think we can get rid of it and just use it. Anytime we use jockey spawned, we actually just check if the jockey's in the graveyard. So anytime we use jockey spawn, let's find our first mention of it. There's only 3, so here's the first one. Not if eggs at I jockey spawned. We're gonna say if jockeys at ith dot graveyard is false, which should be the same as what our jockey spawn was doing. So if we're not in the graveyard and our player collides with us, then we are collected. Yeah, okay. Let's see our other one. Okay. We should be okay. I say that. Where were we just at? God. It's right above our player collision, I thought. Here. Okay. So we're cycling through every egg that isn't in the graveyard, so every egg that's active. We're checking if it's hatched, which we can actually just say, if it's not in the graveyard, And it's hatched, actually. Let me see. Because if it's hatched, we don't send it to the graveyard right away. So we have to say... oh yeah, that's when we send it to the graveyard. So we can actually combine these. We just say, if egg's not in graveyard, and the egg is hatched, that's when we send it to the graveyard. And that allows us to only instantiate one jockey, because this jockey only gets instantiated if we're not in the graveyard and if we're hatched. So we also need to say that hatched gets false. Actually, I don't think we have to, but and it's not graveyard. Oh, yeah. So this is actually different. We're taking the jockey out of the graveyard, but we have to send the egg to the graveyard. So we'll say eggs at the same ith index dot hatched gets false, which doesn't make a lot of sense. But this is and, which is inclusive, so if we send the egg to the graveyard right here instead, we can only instantiate one jockey because it has to be hatched and it has to be not in the graveyard, but we're setting the graveyard true right here. So if we're not in the graveyard and the egg is hatched, that means we are now in the graveyard and the jockey comes out of the graveyard so it can get updated. Then we instantiate our jockey at the egg's last position. What am I missing? Anything else? We've got a jockey instantiation. We've got a jockey coming out of the graveyard where we took out jockey spawn boolean, and our moving to graveyard is now taken care of by the graveyard boolean right here. If we're graveyard, give us that. So I think we're good there. And this needs to be, if not self graveyard. So we're only rendering if we're if our graveyard is false. That makes sense. So jockey comes out of the graveyard. Jockey gets instantiated in the last egg position. We're going to need to shift this by whatever to get it to stand. I don't know where that logic went, but I could have sworn we had to do that because the jockey's like 4 pixels taller or something than the egg. Okay. I'm tempted to just run it and see if everything breaks, which I'd be actually amazed if it just runs, but I do not think that's going to be the case. We update all our pulsars, or all our objects rather, and we do render them all as well. And actually we do the render. Maybe that's redundant then if we have it here in our... Yeah. We don't need to do this because we do it in our play state. So we say our render function includes what to render, but we only render what to render if we're not in the graveyard here. So that gives us the same functionality, just in less words. What do we do? Do we try to run it? See what breaks. Argument expected near eggs. 583. Oh. Egg. Local DT. Huh? DT doesn't get passed in? It does. So we're not... What line does that... Goddamn. Attempt to form arithmetic on local DT. That's not local. It's passed in right here. DT. Are we not updating it? We are updating. See, and I don't know proper, because like if you look at when we update everything right here at the very end. I just want to see if we instead update it first, if it might fix that problem. Oopsie. So we'll go to the top of our update. That's the first thing we're gonna do. PlayState 60 index a nil value. EggsI is not populated yet because we don't do that till right here. So instead of putting it right here, we put it after our tables are populated, which is right here. Then see, I feel like this shouldn't fix it. Yeah, local DT. What? In update, PlayState 104. In function update, egg 86. So... a local DT, homie. This is in our egg update. You have access to DT. Never had that problem before. What are we not doing? We're not giving it DT. We have to give the function DT so it knows what to do with it. Okay, not quite. It didn't completely break like I thought it would, but it is definitely not working. So we are not rendering our eggs. Well, we might be rendering our eggs. They just might not be getting the right values. We are updating each egg in our eggs table. And, oh my god, okay. When do we spawn an egg? Where is our egg instantiation? right here. Well, we instantiate it with dummy values right there. So for some reason, let's just print out, let's turn on our debugging for just the vulture one, and we'll only make one vulture. We'll make it so that on wave 1 we are not instantiating our vulture 2 or our vulture 3, and technically we are instantiating it, we're just not assigning it into our vultures table, which is how we're updating and rendering. So we should have just vulture 1, and then we can print out, we want to print out we also want to print out on screen love.graphics.print. And what do we want to print out? We want to print out our eggs table at the first index, so we can check that it starts in the graveyard and it should get the last X of our vulture upon a collision. So we're going to print out a string that says eggs1.x. We're going to concatenate it with a string of our eggs at index1.x integer converted into a string, and we're going to print it out at 5 on the X and 15 on the Y. So our eggs1x should be printing, and our eggs1x when we're in the graveyard should be -20. So now we can debug if our egg, why is egg x 291? Okay. Why would eggs x be 291? Is it getting the last X of something? Is 291 where vulture 1 is spawning? We go to our play state, we go to our wave 1, we go to our vulture spawning. It's spawning at our spawn zone points at vulture spawn point index.x. So spawn zone points 1. Spawn zone points 1 is platform 3x plus 20. What's platform 3x? 212 is 212 plus 20. 212 plus 20 is 232, not 291. So why is 1x? We shouldn't be updating. Yeah, egg should be in graveyard. Let's make sure egg is in graveyard, because if egg is in graveyard, it should be -20. So now let's print out if egg is in graveyard to see if that's even working. Okay. Okay, this is just... See, I would think that if the egg is in the graveyard, it would be getting... Because if egg is in graveyard, it's getting an X of -20. So what's going on? What if we don't... Like, is our update... Is this not working for some reason? We don't update it, what does it become? What the heck? So it starts off as -10. Is that the graveyard we put it in? Yeah, it is. We populate it with a -10 graveyard. And then for some reason, when we update it, it doesn't. That's so weird to me. Why would it that when we update it, it goes from the graveyard to a 291, even though graveyard is still true? Because we have, if graveyard is true, give it this. There's got to be something that's overriding it, but there's not. I don't even know what to do. If I turn off the update, then when I kill the vulture, the X will still be -10, right? No, what? Bro, how is that getting updated? How is eggs 1 getting updated? It's gotta be here in the, eggs. So look, waves table populated starts as false, or table's populated, and if it's false, then we initialize this. How is it updating if we're not updating it, is the thing. Eggs. Now we need to see update. We don't update our egg. So how is it updating? We've commented it out. So we have to be overriding our eggs somewhere. Are we overriding our eggs X somewhere on accident? Okay. Okay. So you know what? Yeah, I'm stupid. We don't need to update. We needed to run the update function when we had them sequestered off in other classes. But all of our update logic is in the update function of the place state we're currently in. So we don't actually need to be updating, because we're in the update function. So we don't need to be updating. Is that right? No, because we have other values in here that need to be updated. Yeah, we have other values because we have update logic for eggs that aren't in the play state, and those need to be updated appropriately. We turn off update. What happens? We spawn, but we don't get bigger. So we do have to update stuff. God damn. What the fuck? But why would our graveyard, why would update function turning on while our graveyard is true set our X anything other than -20? That's what I really don't get. If I knew where that X was coming from, which I thought it was the platform spawn point X, but it is not. Actually, platform spawn point is random. So is the X random? 291 each time, no matter what spawn point. Yeah. Okay. But it doesn't move when I collide. See, egg should be out of the graveyard upon a collision. So it tells me my tables aren't working exactly right, like I thought, with the for I is 1, comma 3. Because if we collide with any vulture, or no, if we collide and the vulture dies, if vulture's exploded, our egg at the same ith index should come out, but that is not happening. Bro, I don't know how to troubleshoot this. It's just a misunderstanding of how Lua is working. Do we have to, instead of this being I is 1, comma 3, do we try to do the tables or a pairs logic, or k comma v in pairs table, and then we use I as our key, so our k? Maybe. I can't think of another reason why all of this is failing other than this not working correctly. Do we need... I'm pretty sure this I here is local. Maybe we say every I is local. Explicitly to make sure, but I don't know enough about it if it's local to the function, local to the loop, or local to the whole class or the whole play state. So I don't know if that'll fix anything, but let's see for I gets, and we're gonna say for local I gets. See if that changes anything. I remember CS50 saying that Lua treats everything as a global unless otherwise specified, but I have had experiences that suggest otherwise, so I don't exactly know what's going on. Okay, let's save that. Let's see if our tables are getting updated. Oopsie. 85. We need to give ourselves a local I. Fuck. I really don't know. Grasping at straws here. It doesn't like local. Name expected near local. How do local variables work? Yeah. So look, it says scope limited to the block. Yeah, just like I thought. So we shouldn't have to say local, but all we have to do to define local is say local. So I don't know why that's failing. But even then, this is saying it's local to the block it's in. So we shouldn't have a problem calling them just I. Wait. Global. Okay, yeah. Everything's global unless specified local. That's what I've heard. Local to the while body. Local to the then body. Yeah. We could delimit a block. Okay. That's how I was assuming. See if we could step through. If we could step through the debugger, we can see if it's really functioning how I'm envisioning it. I just need to take this out. It should work though, because it's one indexed, so we say I is 1, 3. So I don't understand why it wouldn't be working. I'm stumped. Is there something I'm missing? I mean, obviously. Because it's like the simplest thing of just the egg yard. The egg starts in the graveyard true, where we're printing it that it's true, yet our egg's X is getting assigned some weird ass shit. I guess let's try to pinpoint where that 256 is coming from, or 291. If we can pinpoint where this 291 is coming from, maybe it'll give us a clue to how it's getting assigned in the first place, and maybe overwritten. Because it's like our animation is working fine for our culture and everything. And you know what? If we kill a vulture, where is our player collides? Oh, come on. Player to enemy collision. If we top collide with a vulture, we send the vulture to the graveyard. We change the vultures. Enemy top collides. Oh. Ah, fuck. Enemy top collides. So yeah, they kill us. Move. See, we shouldn't need to move. We shouldn't need to move this, actually. We just send the player to the graveyard. And why would we... Oh, we bounce off. Okay, bounce off makes sense, but changing our Y position doesn't make sense. So if enemy bottom collides with a player, instead of setting the player's Y, we just bounce off. We don't reset our Y. So this one's okay because of where it's our butts touching. And then this one's also okay. If no one explodes, we don't need to not shift our Y. But if someone explodes, we shouldn't be shifting our Y. Which is a bug that's been in there for a while now. Explodes. Oh, well, we didn't have it on all of them. We only had it up here. So at least now, if we top collide, we shouldn't shift and change our... Yeah. It kinda Kind of jacked up the vulture a bit, though. Well, not really. I don't know. So where is this 291 coming from is my question. There's a way to figure it out. As tedious as it might be, we just check eggs at our ith index and see anytime we're assigning a value into the .x, which we're doing. I don't think it's that, but that's the only time. Yeah. It's got to be in the update function somewhere. It's got to be, because yeah, I think we already proved that. If we go to where, god dang, where we freaking update. If we stop updating, our egg stays in the graveyard. Like it's supposed to, but as soon as we update, so why is it that when we update, it goes to our egg update function, and if we turn this off, does that change anything? Nope, 291. So why is, if graveyard is true, and graveyard is true, why is that not overriding it? What if we put this at the end? That's the last thing we write to. We do get the proper graveyard. Why is that the case? Graveyard didn't get set. Oh god. Why did that happen? So yeah, it's like all this needs to be if not graveyard, right? So I guess we can say if graveyard this, else if not graveyard, update all the logic. So update that, we've got an end for it. Okay. So we're at least getting the proper graveyard, but it is still not graveyard false upon a collision, even though we change it to if a player collides with a vulture, if a player collides and the vulture's exploded, we send that egg graveyard to become false. So is there a place where saying graveyard gets true that's overriding this? Let's see. Graveyard gets true on an egg that might be overriding this one. Yes. If egg's not in the graveyard and egg is hatched, graveyard is true. Let's just turn this off for now. And then we're also sending a egg to the graveyard upon a collision with an egg. But this also needs to be, see if not invulnerable. So are we setting invulnerable to true on our egg? I don't think we are. It starts off as invulnerable. We need to set our eggs to become invulnerable so we don't detect the collision right away. So we need to say, and we start off as eggs not collected. So we just need to maybe say eggs invulnerable happens as soon as an egg is spawned. So anytime, let me finish looking at egg graveyard, see if there's any other tricks. No. So we just need to say, whenever we instantiate our egg, if we instantiate our egg, we need to set, we do. We set invulnerable to true. Right there. Do we do it for every case? Yes. Vulnerable true, invulnerable true. Yeah. I don't know what's happening, man. Why would egg's graveyard still be true upon a collision with the vulture? It's almost like, I don't know. My only idea is to, I've got one idea that is, we just test if vulture is graveyard, egg is graveyard, true. Or if vulture is graveyard, if vulture at index, if vultures at index 1 is graveyard true, then set our eggs at the same index graveyard to become false, and then we'll see if it just overwrites it, and then we'll just see if the egg spawns permanent or first off. But my other idea is that the for loops are not functioning as intended. So I would go back to the pairs logic. We would say for key, comma, value in pairs, insert table, then do the logic, and that means we'd have to change all the ith index to a. Or we can say for I, comma, b, or whatever it is, in pairs, whatever it is. So it's just not functioning as expected, so we just gotta dig deeper. I'm gonna call it a day because I'm just kind of at a loss of what to try, and I'm a little tired. We might want to just mass print out a bunch of values. You know what? I want to figure out where that X is getting overwritten. I want to figure out where that X is coming from. Not what I wanted. Where was this 291 coming from before I even sent it? I mean, does it matter? Because we're not doing it anymore because it was in the update function somewhere. We were updating the X, regardless if in graveyard, because it was just getting overwritten. So we fixed that now. So 291 was coming from the update function in our eggs for some reason, but it didn't fix our problem because it didn't set our graveyard to true. It didn't set our graveyard to false upon a collision, because if we collide, where's our player to egg collision, our graveyard, see, this should actually be false. God damn it. Egg is, no. If we collide with an egg, it needs to go back to the graveyard. But let me just turn this off and see if that's what's overriding our graveyard to become true even after a collision. Fucker. It's still overwritten somewhere, so... Oopsie. Not what I wanted. Yeah, if Vulture explodes, our egg's no longer in the graveyard. And if our egg's no longer in the graveyard, we update it with an egg instantiation at our Vulture's last X and Y. Maybe we see what our Vulture's one last X is and make sure that's getting populated correctly. But it still doesn't explain why graveyard would be true. So it doesn't really help us. It'll just illuminate how busted this is. So when we kill this, it should stay, the X should stay the same as soon as we kill it. Yeah. So Vulture last X seems to be working correctly. So that means the placement for our egg instantiation should be working correctly. It's just not getting overwritten for some reason, and I'm really confused why. Yeah. We'll dig further tomorrow. I'm happy the thing's working, like it's not completely busted. Just all our objects are busted, which is to make, not surprising because we changed all our logic for it. We'll just have to dig deeper, dig around, try to see where we're overriding that graveyard. So weird. I'm gonna add everything with a commit message saying finished. Well, what do we even say? Started debugging global object tables, because we finished migrating that stuff out of there, except for our Prince-Core objects, which is a whole nother deal. So we get pushed it, so that'll be it for today, and I'll catch you tomorrow, and we'll maybe figure out some more stuff.